Welcome to the second chapter of me trying to learn Rust. In this chapter, we'll go over chapter 2 in the book. I've decided to go to chapter 2 and not skipping to chapter 3 because I really want to see the Rust language in action before I deep dive into some of the aspects of the language to learn better. So let's start. Programming a guessing game. Let's jump into Rust by working through a hands-on project together. This chapter introduces you to a few common Rust concepts by showing you how to use them in a real program. You'll learn about let, match, methods, associated functions, external creates, and more. In the following chapters, we'll explore these ideas in more detail. In this chapter, you'll just practice the fundamentals. Okay, this is what I was expecting. We'll write some code, some shallow explanation, and next episodes we'll have a better explanation for aspects of the language. We'll implement a classic beginner programming problem, a guessing game. Here's how it works. The program will generate a random integer between 1 and 100. It will then prompt the player to enter a guess. After a guess is entered, the program will indicate whenever the guess is too low or too high. If the guess is correct, the game will print a congratulatory message and exit. Okay, let's set up the project. Cargo, new, let's call it chapter 2. And not guessing game. We'll go into chapter 2 and then fire up VS Code. Let's see that we have the files that we expect from previous. We have the TOML and we have the hello world. Okay, so let's see. Okay, let's inspect this. Looks very similar except the guessing game, except the title looks okay, and we have the main function. Okay, it wants us to try to run, so let's run this. I see it compiled it automatically when I tried to run. This is good. The run command comes in handy when you need to rapidly iterate on a project, as we'll do this game, quickly testing each iteration before moving on to the next one. Okay, this is good. That means that we'll not just get the source code and run it and then inspect the source code. It'll be some sort of like stage by stage developing of this example. Okay, processing a guess. The first part of the guessing game program will ask for a user input, process that input, and check that input in the expected form. Good. To start, we'll allow the player to input a guess, enter the code in listing 2.1. Okay, this is the code. I think we'll just copy it and then go line by line, trying to figure out what we copied. Okay, the first is use std io. I guess that includes some io functionality. Then we print, guess the number. Guess the number. Then we print please enter your guess. And then, okay, let. Now we defined variables. Let mute guess equals string new. Okay, interesting. Forgot to make it into a literal string. Important. So I guess this is squiggly yellow because we're not using anything from the standard library yet. And this is because we're not using this. I guess let, it's a variable, mute, probably mutable variable. So I guess if I do it without let, it's not going to be a mutable variable, like a constant. Name is guess, type is string. Wait, okay, the string is automatically entered from the IDE, and we assign it with a new string. Guess it allocates it somewhere. Yeah, there's something alloc here. I'm not going to go into it, but there is no like immediate allocation handle or anything. So I guess it's some sort of internal allocation. We'll see in the future if I have the opportunity to interfere or maybe set up my own allocations or allocator to allocate strings. We'll see. Okay. So this was this line, and next we do io turn it in. Read line. Oh, it's good. I have the read line and not read char or anything. Mute guess. Okay, that's interesting. I'll finish the line and then we can talk about this. Expect failed to read line. Okay, so, and then print, and then we'll talk about it. Print line, you guessed, guess. Okay, so what we have here is, oh yeah, forgot about this. It's a macro. This is really cool. Okay, so we have standard input. We do a read line. We pass. I think it's a reference. Like, let's see. No. It's a, okay. I assume it's a reference to a mutable something. And this is the reference. I don't see any types here. Like, I would expect it to have like reference to mutable string or something. Maybe it can deduce it by its own. Okay, yeah, I see reference to mutable string. Okay, so just okay. Great. This is the code. Let's read on. This code contains a lot of information, so let's go over it line by line. To obtain user input and then print the result as output, we need to bring the I/O library into scope. The I/O library comes from the standard library known as std. Okay, standard library makes sense. std.io, great. By default, Rust has a set of items defined in a standard library that it brings into the scope of every program. This set is called the prelude, and you can see everything in it in the standard library documentation. So maybe we'll go later to look at it. If a type you want to use isn't in the prelude, you'll have to bring that type into scope explicitly with a use statement. Using the std.io library provides you with a number of useful features, including the ability to accept user input. I didn't understand if like the use std.io brings it or it's already brought in the prelude. We'll see later. As you saw in chapter 1, the main function is the entry point into the program. Yes. The fx syntax declares a new function. Yes, we understood it. The parentheses indicate there are no parameters, and the curly brackets start the body of the function. This is the main scope of the function. Okay. As you learned in chapter 1, print line, it's a macro, root. This is a prompt. Okay, storing values with variables. Next, we'll create a variable to store the user input, like this. Okay, this is the line. Now the program is getting interesting. There's a lot of going on in this little line. Yes, indeed. We use the let statement to create the variable. Here's another example. Let apples equals 5. The line creates a new variable named apples and binds it to the value 5. Okay, this is not immutable. Okay, important. In Rust, variables are immutable by default, meaning once we give the variable a value, the value won't change. We'll be discussing this concept in details in the variables and immutability section in chapter 3. Good. To make a variable mutable, we have to add mute before the variable name. Okay, yeah, like we did here. Note the // syntax. Syntax is a comment. Okay, comment. Good. Returning to the guessing game program, you now know that let mute guess will introduce a mutable variable named guess. The equal sign equal tells Rust we want to bind something to the variable now. On the right of the equal sign is the value that guess is bound to, which is the result of calling string new, a function that returns a new instance of string. String is a string type provided by the standard library that is a global UTF-8 encoded bit of text. Well, the thing with the prelude, I don't know if it's core to Rust or it's like a library. I'm not sure. Like we need to see if string is a core object in Rust or it's something that comes from a library, and then we have to find out what's really the core character representation that Rust has for different applications that we'll do in the future. In addition, so that the equal sign is binding something to the variable now. I think, let's try something. Let's create the apples. Let apples equals 5. That I expect to be orange squiggly, and then let's just print it. Apples. Let's try to run the program. Oh, introduced it's I32. Good. It uses the notation that I like with the integers. Okay, please enter number 5. Now I guessed 5, and I should have entered a different number because the apples is 5. So 15.5, and also I've noticed that the input, the read line, also reads the new line. Yeah, that's important. That reads everything, even the new line sign. I think we'll deal with it later, but it's good to know. So what I wanted to check, if I can just say I have this parameter apples, and then I assign later. Okay, it's even deduced the type from the later assignment. That's good. Let's try to run this, see if it returns the same thing. Good. Okay, so I can declare like a constant variable, so an immutable variable, and then assign a value later. So what happens if I try to put it here? I hope it's an error. Okay, I'm not sure because maybe it evaluates later. Let's try to run this. Okay, this works. Let's try to do this. Let's try to print the value now. Apples. Okay. This is interesting. It's possibly uninitialized, but here it doesn't do this. That's interesting, because both of these are before the initialization. This one yells at me, and this one does not. Let's try to run again. Okay, it yells only here. This is interesting. Okay, we have to watch out for this type of error. I wonder what will happen here. Oh, well, we'll try to trigger this somehow. Let's see, maybe the example triggers this later, and we'll do this example later. Oh, it's not yelling at me at all here. Okay, leave it. Yeah, it actually compiled. I have this variable that I don't have, and it just prints it out. Let's see. I'll leave it in to see if there is an error there. Oh wait, let's try Control C. Yeah, just Control C exit status. Okay, let's continue. Okay, I'm leaving this in just to see if it generates an error when we get into the expect thing. Okay, let's try. Let's see. We stopped here. Okay. The colon syntax in the new line indicates that new is an associated function of the string type. An associated function is a function that implemented on a type. In this case, string. Think like overloading, maybe. This new function creates a new empty string. You'll find a new function many types because it's a common name for a function that makes a new value of some kind. In full, the let mute guess equals string new line has created a mutable variable that is currently bound to a new empty instance of string. Ooh, great. Okay, receiving user input. Recall that we included the input-output functionality from the standard library with use stdio on the first line of the program. Now we can call the stdin function from the IO module which will allow us to handle the input. Okay, this is handling the input. If we hadn't imported the IO library with the stdio at the beginning of the program, we could still use the function by writing this function as stdio stdin. Let's look. Let's try to use this. Okay, good. That means that the use is like a namespace include. Yeah, so we don't have to use this. We can always use the full route, full chain of dependencies here instead of doing use, but this will make it easier. Okay, understand. Okay, next, the line readLines calls the readLine method on the standard input handle to get input from the user. Okay, I'm passing the mutable. Oh yeah, wait, maybe. Oh, I see it. Let's read on. We're also passing mute guess as an argument to readLine to tell it what string to store the user input in. The full job of readLine is to take whatever the user types into standard input and append it into the string. Append it into the string. That's weird. I would expect it to put it into a string. We'll have to test this. I'm writing here comment. Check what append to string mean. Okay. Without overwriting its content. Okay, so it's actually, if I have content already in a string, the read line will append it to the string. That means that the string has some kind of, I don't know, cursor inside that keeps track of where the latest input is, or maybe it's just the length of the string and that's it. We'll have to read about strings a lot, I suspect. Okay, so we therefore pass that string as an argument. The string argument needs to be mutable, so the method can change the string content, of course. The ampersand indicates that this argument is a reference. Yep, okay, let's see what a reference is in Rust, which gives you a way to let multiple parts of your code access one piece of data without needing to copy that data into memory multiple times. Yeah, just like C++. References are a complex feature, and one of Rust's major advantages is how safe and easy it is to use references. Okay, interesting. You don't need to know a lot of those details to finish this program. For now, all you need to know is that, like variables, references are immutable by default. Hence, you need to write mute guess rather than just ampersand guess to make it mutable. Chapter 4 will explain references more thoroughly. Okay, good. So the ampersand works just like C++. Interesting. Still haven't seen any pointers, but I think that there are no pointers in Rust. So let's move forward. Handling potential failure with result. We're still looking on this line of code. We're not discussing the third line of text, but note that this is still part of the single logical line of code. Yeah, this dot chaining is cool. That's a good feature. The next part is the method. Expect, not accept, fail to read line. We could have written this code as iostdn read line, expect fail to read line. Yeah, okay, without going the lines. However, one long line is difficult to read, so it's best to divide it. Yeah, code formatting, it's important. It's often wise to introduce a new line and other white spaces to help break up long lines when you call a method with the method name syntax, dot method name syntax. Now let's discuss what this line does. As mentioned earlier, readLine puts whatever the user enters into the string and pass to it, but it also returns a result value. Result is an enumeration, often called an enum, which is a type that can be in one of multiple possible states. We call each possible state a variant. Chapter 6 will cover enums in more detail. The purpose of these result types is to encode error handling information. That's interesting. Let's read on and then I see if I understand. results variants are OK and error. The OK variant indicates that the operation was successful, and inside OK is the successfully generated value. The error variant means the operation failed, and error contains information about how or why the operation failed. So the result, let's see if I can go into result. It's like it's an enum with OK and error. Okay, I can see, I think you can see that. And they both have values inside. Okay, I think, well, I don't want to go too deep inside, but I'll believe the book. So OK has the value returned, and error has the value that indicates what type of error, I think. Maybe an error string or an error code. We'll see, I hope, soon. So it's nice. Like, we have the enums that I can probably do a switch statement on later, and each enum has a value associated with it, so I can continue working within this branch and maybe doing nicer looking code. So let's continue. Let's read on and see what it becomes. Values of result types, like values of any type, have methods defined on them. An instance of result has an except method that you can call. If this instance of result is an error value, expect will cause the program to crash and display the message that you passed as an argument to expect. Okay, if the readline method returns an error, it would likely be a result of an error coming from the underlying OS. So I guess we'll not see this message ever. Maybe that's why this is not crashing the build. We'll see later. Maybe if we'll have some more excepts, I'll try to put the non-existent apples variable inside. Okay. If this instance of result is an OK value, expect will take the return value that OK is holding and return just that value to you so you can use it. In this case, that value is the number of bytes in the user's input. So I think the expect is like a quick, fail quickly way. Yeah, because if I put it, it'll crash the program. If there's, panics if the value is an error. Okay, so I guess it'll just throw me out if there's an error and stop the program. It's good for debugging. I'll not put something like expect into production code. I think you should like run tests to see that you don't have any like expects lying around in your code when you're shipping. Okay, if you don't call expect, the program will compile, but you'll get a warning. Let's do it. Okay, it runs, but there was a warning. Result may be an error. Okay, result may be an error. Yeah, it's the same warning. Rust warns you that you haven't used the result value returned from readline, indicating that the program hasn't handled a possible error. The right way to suppress the warning is to actually write error handling code, but in our case, we just want to crash the program when a problem occurs, so we can use the expect. You'll learn about recovering from errors in chapter 9. Good. Printing values with println and placeholders. Aside from the closing curly bracket, there's only one more line of code to discuss. It's the print line of the guess. The line prints the string that now contains the user input. The curly brackets said is a placeholder. Think of curly brackets as little crab sensors that hold the value in place. It's standard formatting. Now I think we'll skip this. Oh, and you can format like this. So let's try to do this. Let's see if it works. I can run this. It runs, compiles. Great. So I can use it as both. Just put the variable inside the string, as I did here, or I can just put an empty bracket and then put the variables in an argument list. Great. Oh, I wonder if I can do something like this. I can put an expression inside. Will this work? Okay. It doesn't like expressions. And what if I do this? Okay, good. Okay, so I can't put expressions like in JavaScript inside the curly brackets, but I can do it here, and I can put just variables in these brackets. Okay, good to know. Let's revert. Let's see how it builds, runs. Good. Okay, testing the first part. Just did it. Generating a secret number. Okay, now we're getting into random territory. Next, we need to generate a secret number that the user will try to guess. The secret number should be different every time, so the game is fun to play more than once. We'll use a random number between 1 and 100, so the game isn't too difficult. Rust doesn't yet include random number functionality in its standard library. However, the Rust team does provide a rand crate with said functionality. Okay, I think we're going to some library inclusion things. Using crate to get more functionality. Remember that crate is a collection of Rust source code files. The project we've been building is a binary crate, which is an executable. The rand crate is a library crate, which contains a code that is intended to be used in other programs and can be executed on its own. I wonder if code means open source or not. I'll look into it. I hope it's open source. Cargo coordination of external crates is where cargo really shines. Before we can write the code that uses rand, we need to modify the cargo toml file to include the rand crate as a dependency. Open that file now and add the following line to the bottom beneath the dependencies section header that cargo created for you. Be sure to specify rand exactly as we have here with this version number, or the code example in this tutorial will not work. Okay. Rand equals 0.5 saved. Okay, in the cargo toml file, everything that follows the header is a part of that section that continues until another section starts. In dependencies, you'll tell cargo which external crates your project depends on and which versions of those crates you require. In this case, we specify the rand crate with the semantic version specifier 0.85. Cargo understands semantic versioning semver, which is a standard for writing version numbers. Yep, very good. The specifier 0.85 is actually a shorthand for larger than 0.85, which means that version that is at least 0.85 but below 0.90. I guess it uses the third parameter in semver as a patch number. Yeah, major, minor, patch, and I don't know if it supports build numbers or any other things, but it says it supports semver, so it should. I don't want to test it right now. We'll look into it later if it comes up. I don't think it's very important as long as other libraries work. Cargo considered these versions to have public API compatible with version 0.85, and this specification ensures you'll get the latest patch release that will still compiled with the code in this chapter, as version 0.90 or greater is not guaranteed to have the same API as what the following examples use. Okay, it's good to know that minor versions are expected to break APIs. Now, without changing any code, let's build the project as shown in listing 2.2. Let's do cargo build. And it's compiling. Should have downloaded. I think because I ran this chapter before with some errors, I had some connection issues. It didn't download it this time, but it did download the other time. So yeah, you should have download here. Yeah, I'm seeing different versions of things here because I'm on Windows. I think this one's on Linux. The example. So let's just continue. You may see different version numbers, but they will all be compatible with the code thanks to semver. in different lines depending on the operation system, and the lines may be in a different order. When we include an external dependency, Cargo fetches the latest versions of everything that dependencies need from the registry, which is a copy of the data from Crates.io. Crates.io is where people in Rust ecosystem post their open source Rust projects for others to use. After updating the registry, Cargo checks the dependencies section and downloads any crates listed that aren't already downloaded. In this case, although we only listed rand as a dependency, Cargo also grabbed other crates that rand depends on to work. After downloading the crates, Rust compiles them and then compiles the project with the dependency available. So it tells me several things. One, that it downloads source files. We should look into it and see. It probably stores them in some cache that's not in the Cargo folder, not in the project folder, because it didn't download it this time. When I first ran, I got into this before it crashed, but it started downloading and failed. So I guess it did download and there was another failure, but probably is not downloading the things into the directory, but another, probably some cache or some user data folder on my machine. Okay, let's continue. So, well, now it looks okay. If you open the SRC, the main, and make a trivial, wait, I skipped something. Okay, if I immediately run Cargo build again, it will do nothing. Again, without making any changes, you won't get any output aside from the finish line. Cargo knows it has already downloaded and compiled the dependencies, and you haven't changed anything about them in your Cargo TOML files. Cargo also knows that you haven't changed anything about your code, so it doesn't recompile this either. With nothing to do, it simply exits. If I open, okay, now if I open and I do some change, let's add an exclamation mark and do build again. Okay, it's compiling the code. Okay, here it also compiled the code. That's interesting. Okay, maybe it needs to compile the code every time I'm changing the TOML file as well. We'll need to keep an eye for this. Okay, these lines show that Cargo only updates the build with your tiny change to the main RC file. Your dependencies haven't changed, so Cargo knows it can reuse what it has already downloaded and compiled for those. Yeah, this is, I don't know, I'm afraid that this kind of, I don't know, inclusion, compiling, and download will create the mess that's in npm, in the models folder. I just included one rand library and got, let's see, 1, 2, 3, 4, 5, 6 different libraries, and I don't know their source code. I don't could look and see if all of these are open source. I really hope these are open source so I can avoid a lot of dependencies for the projects. I really don't like it because it slows down compilation. It opens a window for some bugs that I don't know or even can't look into. So I really hope to avoid a lot of this in the future when I'm programming in Rust. I hope it's possible and feasible. Okay, let's continue. Cargo has a mechanism that ensures you can rebuild the same artifact every time you or anyone else builds your code. Cargo will use only the version of the dependencies you specified until you indicate otherwise. For example, say that the next week version 086 of the rand crate comes out, and the version contains an important bug fix, but it also contains a regression that will break your code. To handle this, Rust creates a Cargo log file. The first time you run Cargo build, I have a Cargo log file, and it logs the versions, of all the packages. Let's see, wow, 1, 2, 3, 4, 5, 6, 7, 8. This is my package. 9. So I have 8 packages, not 6. I have 8 packages that I download. Okay, there's source code. That's good. At least I have some links to the source code. I hope it's source code. I'm not gonna go into it right now, but I have libc. Interesting. Okay, we'll not go into it right now. Let's just know that there's a cargo log file, and will, I think, prevent updates unless I delete it or do some cargo flag. Updating a crate to get new version. Okay, this is the when you do what when you do want to update the crate, cargo cargo provides the command update, which will ignore the cargo log file and figure out all the latest versions. Let's see. Nothing to update. Okay. Cargo then write those versions on the cargo log file. Otherwise, by default, cargo will only look for versions greater than 8.5 and less than 9.0. So if the rand crate has released the two new versions, 8.6 and 9.0, you'll see the following if you run cargo update. We haven't seen it, so I guess it's the latest version. Cargo ignores the 090 release at this point. Sorry. If you run cargo, okay, cargo ignores the 090 release at this point. You would also notice a change in your cargo log file. Okay, nothing changes. And if I want to update to 9.0, I'll have to change. Let's see if there's a 9.0 version. Just for fun. Cargo check failed. Let's try to build. There is no. Okay, the latest version is 8.5. Let's build again. Great. Okay. Moving on. There is a lot more to say about cargo and its ecosystem, which we'll discuss in chapter 14. But for now, that's all you need to know. Cargo makes it very easy to reuse libraries, so Rust stations are able to write smaller projects that are assembled from a number of packages. Like, I don't know if it's a good thing or a bad thing, but we'll see what's the ratio of libraries to code I produce. I really hate the, like, you have 100 libraries and 10 lines of code, and then that means that the program you wrote is not yours. Like, every error that you're going to have is error that someone else introduced into the dependencies, and it's dangerous. Okay, generating a random number. Okay, let's do it. Let's start using rand to generate numbers to guess. The next step is to update the main RS as shown in listing to 3. Let's see, we have after this, we have let secret number equals rand red RNG in range. Let's go online, and then the range is 1 point equals 100. I hope they say what it means. No, they probably are. Okay, let's see, and then you have a secret. Just okay, this is the line. First we add the line use. Okay, we need to add this thing here. What? It did it automatically. I wonder if I can do this. I see it's orange. So, but let's see. This. What it says. Okay, it doesn't like it. So maybe there's a reason it's orange. Maybe because it's external, like the stdio, not external. It's like part of Rust. This is external, might be. Yeah, but let's read on. So first we have the line use rand RNG. The RNG trait defines method that random numbers generator implements, and this trait must be in scope for us to use those methods. Chapter 10 will cover traits. Okay, I guess this is a trait, whereas this is just mod. Well, I guess chapter 10 will cover those. Next, we're adding 2 lines in the middle. The secret number is... I missed everything. I just copy it. Secret number is this. Okay. So we're adding 2 lines in the middle. In the first line, we call the rand thread RNG function that gives us the particular random number generator we're going to use, one that is local to the current thread of execution and is seeded by the operating system. That makes sense. I wouldn't want to have a random number generator that's not tied to a thread, that's like global, not thread safe, and like if you have a random number generator because you can't know the execution order of different threads, there's no meaning of keeping it global and not just splitting it into different threads to have like different instances of the random object. So yeah, that makes sense. Then we call the genRange method on the random number generator. This method defined by the RNG trait that we brought into scope with the use rand RNG statement. The genRange method takes a range of expressions as arguments and generates a random number in the range. The kind of range expression we're using here is to take the form start dot equals end, and it's inclusive on the lower and upper bounds, so we need to specify one dot equals 100 to request a number between 1 and 100. Let's just try to build it really quickly. It works. So I guess if this is inclusive, this is exclusive on the, and it builds. Okay, we'll test it later, I think. But we should remember this is inclusive. Great. You won't just know which trait to use and which method and function to call from a crate, so each crate has a documentation with instruction for using it. Another neat feature of Cargo is that running cargo doc open commands will build documentation provided by all your dependencies locally and open it in your browser. If you're interested in other functionality in the rand crate, for example, run cargo doc open and click rand in the... Yeah, let's see. Doc open. It builds documentation and opens documentation. Let's try to find I don't know, the genRange function. Okay, you can see it here. Chacha 20. Yeah, so I have some documentation for this. I can get a U36 F64. Oh, good. I like this number notations. This is good. Yeah. So here we can see. Okay, open, enclosed, good. Like inclusive and exclusive. Sorry, this is the inclusive. This is the exclusive. Yeah. I won't read it right now. We'll continue the chapter, and then when we talk about ranges, I think in future chapters we'll deep dive into this. The second new line prints the secret number. This is useful while developing the program to be able to test it. Yeah, but we'll delete it from the final version. It's not much of a game if the program prints the answer as soon as it starts. Okay, let's try running the program a few times. This is run. I have to compile again. That's weird. Okay, now secret number is 13. Secret number is 93. Secret number is 67. Okay, good. The random number works. Okay, let's continue comparing the guess to the secret number. Okay, yeah. Now that we have user input and a random number, we can compare them. The step is shown in listing 2.4. Note that this code will not compile. Okay, let's see. After you guessed, match, and then I have guess, compare secret number, and then I open a scope. I think it looks like a switch statement. Yeah, so ordering less goes to print line too small, comma, ordering greater not auto-completing, print line too big, and the last one, ordering equal goes to print line you win, and then a comma. Oh, so I can do commas at the end. Very good for formatting. Okay, so I have this. I need to include something. Okay, ordering. Yes, I need to include this. Yes. Okay. Good. Okay, first we add another use statement, bringing a type called ordering into scope from the standard library. The ordering type is another enum and has the variance less, greater, and equal. These are the three outcomes that are possible when you compare two values. Makes sense. Then we add 5 new lines at the bottom that use the ordering type. The compare method compares two values and can be called on anything that can be compared. It takes the reference to whatever you want to compare with. Here's the comparing guess to secret number. Then it returns a variant of the ordering enum we brought into scope with the use statement. Okay, so this is just returns ordering and an enum. Okay. When we use match expression to decide what to do next. So match is a switch statement, yeah. But the next, based on which variant of ordering was it returned from the call to compare with the values in guess and secret number. Okay, why it's red? Because it's integer and string. I guess this is the problem that we'll have to convert the inputs into an integer. But okay, let's look at this. Like we have the compare method on the guess string. I wonder if the compare if it's polymorphism or, well, not polymorphism, but classes, or is it a function that overloads an operator? Yeah, it's the function self. So yeah, I guess it's like a member function, a method, if you will. Yeah, so there's like string as a method called compare. Okay, and compares, it returns an enum, and then match probably takes an enum, like switch this variable, and for each case match it'll run string. Okay, I think I understand. I think I get it. Match expression is made up of arms. An arm consists of pattern to match against, and the code that should be run with the value given to match fits that arm pattern. Rust takes the value given to match and looks through each arm's pattern in turn. Patterns and match constructs are powerful Rust features that let you express a variety of situations your code might encounter, and they make sure you handle them all. These features will be covered in detail in Chapter 6. Okay, Chapter 3, 4, 5, 6 looks like they're going to be reading heavy. Okay, and 18 respectively. Okay, let's walk through an example with the match expression we use here. Say that the user has guessed 50 and the randomly generated secret number is 38. So when the code compares 50 to 38, I'll just skim through this. I think it just explains what's greater, less, and equals. I think I understand. I'll run some tests after we can compile this program, and I think this will help us compile. However, the code in listing 2.4 won't compile yet. Let's try it. Yeah, let's try to compile the code. Build. Yeah, it throws an error because expected string found integer. So yeah, guess is a string. The secret number is an integer. We'll have to do some conversions so we can do the comparison. Let's go in. The core of the error states that there are mismatched types. Rust has a strong static type system. Very good. However, it also has a type inference. When we wrote let mute guess string new, Rust was able to infer that guess should be a string and didn't make us write the type. The secret number, on the other hand, is a number type. A few of Rust's number types can have a value between 1 and 100. And 100? Okay. A few values can be between 1 and 100. I32, a 32-bit integer, U32, an unsigned 32 number, I64, etc. I'm familiar with this notation of integers, and also we saw the floats before, so I'm not going to go into this. Ultimately, we want to convert the string the program reads as an input into a real number, so we can compare it numerically to the secret number. We do so by adding the line to the main function body. Okay, let's see what line. Okay, this one. So let's write it. Now we do. Wait, no, it's after the standard input type. So let guess U32 equals guess trim. Trim removes white spaces probably. Parse. And then expect again. Oh, this is an opportunity to fail, I think. Please type a number. And of course, because I'm splitting the screen, I'll do this. Okay, so let's see what we got here. I think we're shadowing the function. Let's see. This is guess string, and this is guess U32, and if I do this, no, this is U32. Okay, so this is cool. Like basically, what I can do, maybe it's written here. I can have a variable with the same name but different type, and then from this point, from the line 22 onward, when I'm using guess, I'll be using this guess and not this one. And I don't see any warnings about this, so that's weird. I would expect to see a warning that I'm reusing a variable name, but let's go forward and see. First of all, I'll add the apples here. Let's see what it says. Still no error. That's interesting. Still no error. I put a non-existent variable here in this string, and it's not producing an error. I think here I could do an error manually. So let's read on and see what will be there. Okay, this is the line. We create a variable named guess, but wait, doesn't the program already have a variable named guess? It does, but helpfully, Rust allows you to shadow the previous value of guess with a new one. Shadowing lets us reuse guess variables names rather than forcing us to create two unique variables, such as guess string and guess. For example, we'll cover this more in chapter 3. Good. But for now, know that this feature is often used when you want to convert a value from one type to another type. Yeah, especially when you do some, tokenization and parsing of like external input files. This is very helpful. We bind this new variable to the expression guess trim parse. The guess is in expression refers to the original guess variable and contain the input as a string. The trim method on a string instance will eliminate any white space at the beginning and the end, which we must do to be able to compare the string to the U32, which can only contain numerical data. Yeah, trim, very common operation in strings. The user must press enter to satisfy the read line and input their guess, which adds a new line character to the string. For example, if the user types 5 and press enter, guess looks like this. I think in my case, oh yeah, in Windows, it's you have a carriage return and a new line. And the trim eliminates all of them. Good. The parse method on strings converts a string to another type. Here we use it to convert from a string to a number. We need to tell Rust the exact number, the exact number type we want using. That's why I'm using. Where is it? Here. It's a bit, here we wrote it explicitly. Sorry. Here it's, I think, the IDE adds this, but here I had to write the U32 explicitly. I think for the parse to be able to resolve to a type. Yeah, it looks like there is a template for the parse that depends on the usage. Okay, good. Additionally, the U32 annotation in this example program and comparison with secret number means Rust will infer that the secret number should be U32. Oh, I haven't noticed. Like if I remove this, then it's reversed to I32. Interesting. That's really good. That's really good. Like, okay, let's see. The parse method will only work on characters that are logically be converted into numbers. I get like hash probably will also work, and so can easily cause errors. For example, the string, there will be no way to convert that to a number because it might fail. The parse method returns a result. Let's see. Yeah, returns a result, much as the read line method does, discussed earlier. We'll treat the result the same way by using the expect method again. If parse returns an error result variant because it couldn't create a number from the string, the expect call will crash the game and print the message we give it. If parse can successfully convert the string into a number, it will return the OK variant of the result, and expect will return the number that we want from the OK value. Now let's run the program. It works. Okay, let's just do 5. Too small. Okay, it works. Now let's try to cause it to crash. Let's see. Please type a number. Apples. Okay. That's it didn't even try to do the formatting here. Let's see. This is okay. Let's see the inputs here. Don't know what's the input. Okay. What's the input here? Wow. I think it's too much. Let's go to print. Okay, this print. Can't see what's the input here. That's weird because it disregards this bracket here. Just it's not. It seems like I can't format here in the expect. Okay, that's why I didn't error when I tried to build it. Okay, and now when I do this, yeah, I get just this string and with a parse int error kind invalid digit. Okay, let's continue. Okay, so now we know why it didn't why it let us compile this without apples being defined. Okay, nice. Even though spaces were added before the guess, the program still figured out they want me to add spaces. Yeah, it works. Trim works. Run the program a few times to verify the different behavior with different kinds of input. Guess the number correctly. Guessed too high and too low. Let's do it very quickly. The number 32 is 3. Too low. Let's do a high number. And let's do the exact number. Yeah, a win. Okay, allowing multiple guesses. Now we get into loops. Okay. The loop keyword creates an infinite loop. We'll add a loop to give users more chances of guessing the number. So where's the loop? It's enter your guess. Loop. and it goes around everything. Okay. Oh, cool. It says that this is the function main. It doesn't say anything here. Maybe just for functions, not for scopes. Okay, so now we have the loop. Let's just run it. 5, 6, 7, 81. Well, yeah, there's no exit. I just do this and I fail. Okay, as you can see, we've moved everything from the guess input prompt onwards into a loop. Be sure to indent the lines inside the loop, another 4 spaces each, and run the program again. The program will now ask for another guess forever, which is actually introduces a new problem. It doesn't seem like the user can quit. The user could always interrupt the program by using the keyboard Control-C. Okay, good. But there's another way to escape this unsuitable monster. As mentioned in the parse discussion, yeah, we can fail. Yeah, I think that's what they did here. They typed quit and it failed, similar to how I failed. Okay, there's an option to do it with a stack trace, the Rust backtrace. Maybe I'll add this into the environment later. No, it's not relevant, but I'll remember that I have a Rust backtrace thing I can use. Okay, typing quit will quit the game, but you'll notice, so entering any other non-number input. Okay, quitting after correct guess. Okay, so yeah, instead of doing just a print, I'm opening a scope here. And then after I print, I break. Okay, that's good. So let's just check it. If I do 10 and then 23, I win and it quits. Okay, so now we have still the 2 expects here. Handling invalid input, yeah, makes sense. To further refine the game's behavior rather than crashing the program when the user inputs a non-number, let's make the game ignore a non-number so the user can continue guessing. We can do that by altering the line where guess is converted from a string to a U32 as shown in listing 3.5. Okay, so let's get, I think this is it. Let's guess trim parse, and then instead of this expect, we're opening scope. Am I missing something? Oh, missing a match here. Okay, so we have a match. Wait, parse returns. It returns an enum with the OK and error thing. Yeah, okay, so doing a match and then I'm doing OK. This is weird, but I guess it'll tell us what it does. And then I have error goes to continue. Okay. Sorry. Okay. Let's just see what happens. Yeah, just ask for it again. Good. Okay. We switch from an expect call to match expression. Switch and match. Expression to move from crashing on an error to handling the error. Remember that parse returns a result type, and a result is an enum that has the variance OK and error. Yep, good. We're using a match expression here, as we did with the ordering result of the compare method. If parse is able to successfully turn the string into a number, it will return an OK value that contains the resultant number. The OK value will match the first arm pattern, and the match expression will just return the num value that parse reduced and put it inside OK. That number will end up right where we want it in the new guess variable we created. Okay, so I guess this is some sort of like naming the value inside this enum. We saw that enums can have values assigned to them or inside them. I'm still not sure, but we'll see it in the next chapters, I think, of how enums are structured in Rust. It's different than enums I know. But here we have the enum, which is automatically U32. So I guess this denotes from the enum of the OK value. and this one is parse int error. That means that each enum may have different types associated with it. If parse is not able to turn the string into a number, it will return an error value that contains more information about the error. The error value does not match the OK_num pattern in the first match, but it does with the error underscore pattern. The underscore is a catch-all value. In this example, we're saying we want to match all error values. That means that I can do something like this. But with different value, like with different types of errors. That's interesting. Let's actually, I wonder if I can print this. Let's try to do something like this. And let's print the underscore. No, let's do it like this. I want to format error parsing number, and let's try to run this. Doesn't like it. Yeah, of course. Silly me. Still, doesn't like this. Environment. Okay, let's try to do this. Okay. This is interesting. The underscore. Yeah, wait. Yeah, invalid error parsing number, invalid digit found string. So if I give a name, that I'm getting a variable. If I'm doing an underscore, then I have no value in just this. Let's quit. No, I have to save. And then here, yeah, just enter guess, and secret number is 12, and I win. Okay, so let's read about this. The underscore is a catch-all value. In this example, we're saying we want to match all error values no matter what information they have inside them. So the program will execute the second ARM code continue, which tells the program to go to the next iteration of the loop and ask for another guess. So effectively, the program ignores all errors and parse might encounter. Not everything in the program should work as expected. Let's try it. Yeah, we already tried it. Awesome. Great. We'll finish guessing game. Recall the program is still printing the secret number that worked well for testing, but it ruins the game. Let's delete the secret number. Okay. The output's okay. Let's read the summary. This project was hands-on way to introduce you to many new Rust concepts. Let, match, functions, the use of external crates, and more. In the next few chapters, you'll learn about these concepts in more detail. Chapter 3 covers concepts that most programmer languages have, such as variables, data types, and functions, and shows how to use them in Rust. Chapter 4 explores ownership, a feature that makes Rust different from other languages. I guess it's the reference thing. Chapter 5 discusses structs and methods syntax, important. And Chapter 6 explains how enums work. So I think Chapter 3 to 6 will be, mostly reading, maybe some testing. I did want to test something about the read line. Yeah, because it depends. So let's see if it actually if I put this here and I compile, and then I do 5, then 6. It should depend. Yeah. I want to print, right? I want to print the guess function. Please enter your guess, and right after this, I'll print guess. Sorry. Guess. I just want to see if it actually appends or overrides. Print line. It will take me some time to get used to this. Okay, so 5, then 7. Guess 5, 7. Okay, yeah. So it actually appends, and also it depends after the new line Interesting. Okay, so I'm going to get this back. Get this back here. This back here. And with this. And then try to play the game again for less time without printing this also. Yeah, please enter guess. 70, too small. Ooh, 90. Ah, I didn't save. Yeah, I need to move this here for it to work. Great. Yeah, 50, too small. 80, too big. 70, too big. 60, too big. 55, too big. Wow. 54, 51, too small. 52, 53. Yay, I win. 53. Thank you. Next time we'll do chapter 3. Bye.